Alright, so type 2, naming ionic with a transition metal. And this is transition metal.
Yeah, if it's anybody.
Alright, what groups are the transition metals? Make sure you have out your periodic table. Have it out because you're going to need it. 3 through what? 12. Yes, groups 3 through 12. This also includes SN and PB, which are at the bottom of groups 14. So now we're talking about our metal. Our first element is in groups 3 through 12, or it's SN and PB. We're going to have to name it differently. Follow a little bit different rules. So what do we know about the transition metals? How are those metals different than the group 1 or group 2 metals? What do we know about them? Kaylee?
They don't have like a definite charge.
Exactly. They don't have just one set charge. Their charges can vary. So how do we know which one we're talking about? Well, we have to include it in the name. All right? So we're going to put up here, charges can vary. All right, so to name these. Step number 1, we're still going to name the metal first. But now this time when we go to find our metal on the periodic table to name it correctly, we notice that it's in our transition metal range. So my example is going to be Cu(I)2. Alright, so you might already know, but just find it. What group is Cu in on the periodic table? What number? 11, right? So it's in that 3 through 12 range. What element is Cu?
Copper.
Copper. So we're going to name it copper. Alright, and we know it's a transition metal. Alright, so now step 2. We're going to indicate the charge of the metal in Roman numerals in parentheses. So because the charges can vary, we have to indicate which one we're talking about by putting the charge in the name. Alright, so how can I figure out which charge copper is here if all I'm given is Cu(I)2? Dusk?
Reverse cross method.
Yeah, the crisscross method was we would look up the charges and cross them to get subscripts. So we're going to reverse that. So right now, what's my subscript for copper? 1, right? There's a 1 here. So I'm going to reverse this, and that becomes -1. And I'm going to reverse this, and that becomes +2. Now we always need to check our non-metal because that has a set charge. So find iodine on your periodic table. Is iodine a -1?
Yep.
Yep. So that means copper is what charge? 2. All right, so now after copper, I'm going to come over here and in parentheses, I'm going to put a Roman numeral 2 because we want the charge of our metal, which was copper. So Roman numeral 2. All right, so now step 3, we're going to name the nonmetal with the suffix "ide," just like we did before with the binary ionic. So iodine is going to become what?
Iodine.
Iodide. So copper 2 iodide would be the name. So what's the only difference with this type versus our binary ionic compounds? The Roman numerals, step 2, because our charges can vary. So we're indicating the charge of our transition metal in the name. Only difference. So we need to make sure we know the Roman numerals for at least 1 through 6. Okay? So I is 1, 2 I's is 2. 3 I's is 3. Alright, I'm going to skip one. V is 5. So if you do IV, that's 1 before 5, so that would be 4. If you do VI, that's 1 after 5, so that would be 6. So make sure you know at least the Roman numerals for 1 through 6. Any questions on this part? We're about to do some more examples. Good? Can I erase this? Are we good? Everybody's good? Alright. First example. MnCl. MnCl. Alright, so find Mn on your periodic table. What group is it in? 7. So it's in my 3 through 12 range. What element is Mn? Manganese. So we're going to name it first. Manganese. Alright, we know it's a transition metal, so we have to put our charge in Roman numerals in parentheses, but we'll get to that. And what's chlorine going to become? Chloride. So anytime our metal is in that transition metal range, we're going to have to do the uncrossing of our subscripts. Alright, so right now, what are my subscripts? 1s, right? So I'm going to uncross. This becomes -1. This becomes +1. And we check our non-metal. Is chlorine a -1 charge? Yes. So that means that manganese has what charge? +1. So we come over here, and what Roman numeral do I put? 1. Manganese, 1, chloride. So we're only putting this number in our Roman numerals, the charge that's on our metal. All right, next one. What group is Cu in on the periodic table? 11. So it's in our transition metal range. What is Cu? Copper. So we have copper. We know it's a transition metal, so we're going to have to put the charge in the name. And what's phosphorus going to become? Phosphide. Alright, so now we're going to uncross our subscripts. I have a 3 here. What subscript is here? 1. So if there's nothing, it's an understood 1. So I uncross my 3, that comes over here. I uncross my 1, that comes over here. Is phosphorus a -3 charge?
Yes.
Yep, so what's copper's charge? 1. So what Roman numeral do I put? 1. Copper, 1, phosphide. Now we would love for all of them to work out this perfectly, but sometimes they don't. So my next 2 examples are when they don't just uncross and happen to be that number. So this is why we always have to check our nonmetals charge, because our nonmetals have set charges on the periodic table. So we always got to check. Alright, so my next one, SNO. So remember, SN and PB are at the bottom of group 14. They're those 2 elements that act like transition metals. Alright, so what is SN? What element? 10. So 10. We got our charge here. And what's oxygen going to become? Oxide. Alright, so right now, what are my subscripts? 1s. Alright, so if I uncross this, I have a -1. Uncross this, I have a +1. Is oxygen a -1 charge? No, what's its charge? -2. Which means that my subscripts were reduced. So I have to double this charge to get it back to the original. And whatever I do to this one, I doubled it, I have to do to this one. So I'm gonna double it also. So what was my charge of 10? 2. Because look, my charges were 2s. What happens if they're both 2s? They reduce or they cancel, right? And they become 1s, which is why my subscripts were 1s. But they were originally 2s. So this would be 10 what? 2. 10, 2 oxide. So that's why we always have to check our nonmetal. Because if we have to double to get back to the original charge, whatever you do to one, you have to do to the other. All right, and last example down here. What's PB? Lead. All right, and we know that lead and tin act like transition metals, and we have to include their charge in Roman numerals. And what's sulfur going to become? Sulfide. All right, so this time, what's my subscript on lead? 1. So I uncross this 1, that's -1. Uncross this 2, that's +2. Is sulfur a -1? Nope, what's its charge? -2. So if I double this one, what do I have to do to this one? Double it, and what's it become? 4. So this is lead what? 4. Sulfide. Lead 4. It doesn't happen a ton like this where you have to change your subscripts. Most of the time, you uncross, you check your nonmetal, and that's what it is. But sometimes they are reduced, which is why you always need to check your nonmetal. Always. Always check it just to make sure you don't need to either double it or maybe even triple it. Because what if you had something like this? M and N. Right now it's 1 and 1, but if you look up nitrogen's charge, what is it? 3. So what does that mean manganese was? A 3 before it was reduced to 1 and 1. So you always have to check that nonmetal's charge. Okay, don't just assume it's whatever subscript is over there. You know what happens when you assume. Lyric will tell you, she knows. Yeah. Okay, alright, so, we're not done. What about the reverse? I think that this type is easier doing the reverse because, if I can ever get to the slide. There you go. Because look, do you have to look up copper's charge?
No.
No? What is it in number 1? 2. It gives you the charge. Because if we went to go find copper on the periodic table, we wouldn't know. So that's why it's included in the name. Alright, so for the first one, if we're trying to find the formula, are we still going to cross charges?
No. Oh, you would?
Always for ionic. Alright, so if it's copper to bromide. Alright, I have copper. Is this going to be a superscript or a subscript? Super up high, sub down low.
I couldn't tell you.
Superscript, it's the charge, right? This indicates the charge of copper, not the subscript. So this is +2. Alright, what element would bromide be? Bromine, because we learned that when we name anions, we change their ending to "ide." So when you see "ide" on an element, it just means that element. So this would be bromine. And what's bromine's charge? -1. So when I cross those, let's see here. Alex, what'll be my formula?
CuBr2.
Yep, perfect. CuBr2. Alright, next one. What's iron's charge here? 3, right? Fe plus 3. What's nitride? What element would that be? Nitrogen, right? And what's nitrogen's charge? -3. So Sean, what would this formula be?
Fen.
Fen, right? My 3's are going to cancel out. Good. Fen. Alright. Next one. What is lead's charge?
4.
4. Lead, 4. So it's Pb plus 4. What element is oxide? Oxygen. And what's its charge? -2. So Kadiris, what formula is that going to be when I cross them? Pb2O 4. And then can I reduce that? A 2 and a 4? So what would it be? Divide both by 2. So Pb 1 and then O 2. PbO2. Alright, and last one. What is gold's charge here? 5, right? Gold, V is 5. So this is Au plus 5. What element would selenide be? Selenium. So what's its charge?
2.
-2. And when I cross those, Maddie, what would be my formula?
Au2Se5.
Yep, Au2Se5. Perfect. So I think these are a little easier because you're already given one of the charges. It's in the name. You don't even have to look it up. Questions on transition metals? Alright, so for your assignment, I have 10 of them that you're naming, and 10 of them you're writing the formula. So when you're done, turn it in.